Take a look at this sequence. It isn't immediately obvious how we could write a term of this sequence as a function of n. One thing that does stand out to me is that each term is 2 times the previous one. 6 is 2 times 3. 12 is 2 times 6, and so on. So this suggests another way that we can define the terms of a sequence, where each term is defined not in terms of its place in the sequence, but instead in terms of the value of previous terms. So we can use this observation to define the nth term of this sequence as 2 times the n minus first term. Now, to make this definition complete, we also have to specify an initial value, right? So here in this case, I would say a sub 0, or we started at 1 over here, didn't we? So let's do 1. A sub 1 is equal to 3. The name for these sequences, where the definition is based on the values of previous terms, is what we call a recurrence relation. And this new method of defining a sequence and its relation to the earlier index-based definition is going to be our focus for the remainder of this section. In the next lecture, we're going to look at 2 examples of well-known recursively defined sequences to kind of give you a feel for how these things are defined and what these definitions look like.